Hello, everyone. Welcome, and I'm going to, as Ben said, do a little quick intro here to Dynamo for you. Now, I just want to give you just a brief background. I mean, most of you may know me as the Revit guy, the guy that does all the the Revit books and the Revit video training at lynda.com and LinkedIn Learning, and that's all true. So I'm fairly new to Dynamo. When I say fairly new, I've been working on it for a couple of years now, but I have an architectural background. I don't have a computer science background. So I think that's both a strength and a weakness, potentially, depending on your point of view. I think it's a strength in the sense that for all of you who are in a similar situation, you're a building professional of some kind, architect, engineer, what have you, then hopefully you'll see that you don't actually have to have a computer science background to use Dynamo. And Dynamo it's kind of like a bridge almost between what we do, the work we do in Revit, and the behind-the-scenes work that we could do with programming in the API. API stands for Application Programming Interface. So the API is how programmers can actually create plugins, much like the ones you probably have seen from CTC, for example, the Express tools. Those are all created in the API. So when you are a serious programmer, developer, and you want to create functionality that does a certain thing with an interface, a user interface, and that kind of thing, interaction with the user, you would use actual coding and the API. Dynamo is more about kind of having almost like a partner working alongside of you as you work in Revit. So you can be doing things in Revit and then realize that you've run into something that maybe could benefit from either some higher level functionality, or there's a lot of repetition in about what you're about to do. Maybe you're going to do the same task about 100 times, and the thought of doing that is really disheartening. So those are places where Dynamo can really be a big help, because it can help you either run that repetitive task over and over again, or it can help you iterate through possibilities, or use it to access functionality that's in the API that isn't necessarily exposed in the user interface of Revit. So those are all places where Dynamo might be of benefit. So I'm going to show really just two very simple examples to kind of illustrate this point. One will be a graphical example where we're going to actually place some elements in a Revit model, and then the other is going to be a little bit more just kind of project management level stuff. So we're gonna change the names of a bunch of views in a project. So both of these things, I hope you'll see, have some practical application in your day-to-day workflow. But again, they're really just meant to give you an idea of what's possible. Now, if you're already a Dynamo user and you've been writing, creating graphs for a long time and everything, then nothing I'm going to show you is terribly advanced. So you might find this more of a review. But if you're brand new to Dynamo, then I'll try and explain the concepts along the way as we go. And again, remember that the explanations are coming from the point of view of a Revit user as opposed to a computer science person. So hopefully you'll find that valuable. All right, so without any more introduction, Dynamo is really in two parts now. So you're going to find these on the Manage tab. I'm in Revit 2018, actually specifically 2018.2. Where in 2018.2 there was a new version of Dynamo that was introduced, which I believe is 1.3 something. So I might have that wrong. But anyway, there was a new version of Dynamo. So just in terms of if you're trying to replicate what I'm doing and whether things look slightly different, it might be the version of Revit that you're working in. But I'm in Revit 2018.2 and Dynamo 1.3, I believe. Now, there's two buttons here on the Manage tab under Visual Programming. There's Dynamo Player and Dynamo. I'm going to start with the Dynamo Player. What I like about this is I can actually show you what the graph is going to do before we build it. Okay, so what Dynamo Player is designed to do is just to allow you to create scripts in Dynamo. We call Dynamo files either scripts or graphs, and that's just a workflow that we want to run in a Revit project. And if you want to distribute those to your team, you can put them in a folder. Here's the sample folder that comes with the software. And if I click this little button right here, it's going to show me where that folder is. So it's on my C drive, program data, Dynamo, blah, blah, blah. It's in this big long path here. But these are some sample Dynamo scripts that are provided with 2018.2 that you can run. And, they do things like add levels or, calculate room occupancy and that kind of thing. Right next to that, there's another button here where you can actually browse to a different folder. So in what I've done is prepared some files and put them on my D drive. So if I can just find my D drive here, and then this Dynamo folder, and that'll load a different collection of scripts. And then you can run one of these scripts by simply clicking the play button. So what I'm going to do is these two lines that are here, I want to place families along those lines. Okay, so I'm going to try running this. I'm not sure if it remembers the selection, so it'll either work or it will generate an error saying it doesn't have a selection. We'll find out together here. So let's run it. And if it does generate the error, I'll just show you the next part of, there you go. It did remember the selection. Okay, so that's perfect. So you can see what it did. It created a bunch of, trees along those paths. Now, this one would have been fairly easy to do yourself directly in Revit because it's along a linear path, and we could have just simply done an array. This one a little more challenging because it goes along a spline path, and there really isn't any way to do that in the standard Revit user interface other than to just manually place each one of those trees. Now those could be, I'm using trees here, they could have been they could have been people, they could have been furniture. It doesn't really matter what you're putting along that path, but because I'm following an irregular path, a little bit more challenging to do that, so that's a place where Dynamo can help. Now, what I was starting to say was if it didn't remember the selection, there are two little icons right here on Dynamo Player. There's this one and this one. This one allows you to edit the graph in Dynamo. We're going to build the graph actually from scratch, so we're not going to do that one. But this one says Edit Inputs, and what that does is it shows you any of the inputs that you can interact with in this particular graph, and the one that I was alluding to was this one here, the selection. So it remembered these two elements, which is this curved line here and this straight line here, and that's why the graph worked without an error. But had it forgotten what those two selections were, then it would have generated some sort of warning, and we would have just simply gone here to this inputs, click select, and then select those two lines, and then run the graph again. It would have worked just fine. Okay, so so that's what we're after. That's sort of the final result. Now you can't have both Dynamo Player and Dynamo open at the same time. So I'm going to close Dynamo Player, and all of your Dynamo actions will actually show on your undo stack. So what I'm going to do is just sort of undo the Dynamo script right here, and that's going to reset me back to where I started from. And now I'm going to launch Dynamo with the button right next to Dynamo Player. Now Dynamo does run in a separate window, and I've got sort of tight screen real estate here in the webinar, so I'm going to have to kind of move my windows around to show you what's going on back in the background in Revit. But Dynamo tethers itself to the active Revit document. And so this is important when you're using Dynamo for Revit, because you have to start first by opening something in Revit, which we've done, right? I've got this starter file here with the two model lines in it. And then you have to then create or run a script on that file. So I'm going to click New here, and I'm going to build this script from scratch, the one that we just saw. Okay. Now, the first thing I want to do is sort of a quote-unquote hello world example, but I'm going to do it with geometry as opposed to text. So if you've ever taken a computer programming class anywhere at community college or at a seminar or what have you, there's usually the hello world example where they try and show you how easy it is to program. And so they write a little bit of code, and then they press a button, and then the words hello world appear on the screen, and everybody goes, ooh, ah. Well, the sort of equivalent of that, graphically speaking, in Dynamo would be to create some quick geometry, right? So what I want to do here is to show you how we can start to use Dynamo to create things, right? So I'm going to create a simple point, okay? I know, very exciting, but let's start with that. So Dynamo is organized over here in a library, and if I expand these groupings in the library, they often have subgroupings and then sometimes even more subgroupings. And so at first, I recommend that you browse through the library and try and find where things are. And then eventually, you'll notice there's a search field up at the top. You'll be able to search for things because you'll kind of remember that you need this or that node. So the way that Dynamo works fundamentally is there are nodes, which are little pre-written blocks of code, and then there are wires which connect the nodes together. So you drop a bunch of these nodes on your canvas, and then you just simply wire them together in the order you want the data to flow. And everything flows from left to right. So let's just go ahead and look at a really simple example of that. So we're in geometry. I'll scroll down here to point right there. And you can see in this plus grouping here, these are all the different ways we can create points. Now I'm going to do a simple by X and Y coordinate. I think most of us are familiar with that concept. So if you look at this graph paper in the background, the X-axis is this red axis and the Y-axis is that green axis there. And if we kind of move this out of the way, up here at the top there are two little buttons, and right now if I drag my wheel on my mouse or I zoom my wheel on my mouse, I'm actually zooming and panning or navigating the graph itself, which is kind of like a layer sitting on top of the 3D space. But if I click this button, it shifts me into the 3D space, and now I'm zooming or panning within that 3D space. And if I hold the Shift key and or I'm sorry, that's Revit. In Dynamo, you just hold the right key, the right button down and drag it. You can kind of orbit it a little bit. But what you'll notice here is there's already a point there, okay? So the reason for that is that this little block of code has just enough code to say create a point. Now, you can see that it's going right to the origin point, and the way you can tell that is because if you hover over the items on the left-hand side, these are called inputs. Those inputs will tell you two things. It'll tell you what kind of data they expect and if there's a default value. Now, not every input has a default value. So sometimes when you drop a node in, it doesn't do anything until you connect a wire to it. But in this case, because there's a default value of 0 in both cases, right, X and Y, it's putting a point there for me. So I've already got a point right at the origin. Now, if I were to move this out of the way, there's this little blue dot here in Revit. Now, that's not really a real Revit thing. Like if I were to close Dynamo right now and refresh my Revit screen, that blue dot would go away. So there's actually a difference between geometry in Dynamo and geometry in Revit. And we're going to see that as we build this graph, that we're going to take Dynamo geometry and kind of convert it to Revit geometry and vice versa, okay? So in this case, we've got a point here. Now, if I want to move this point somewhere else, I just need to feed in a different input in either X or Y or both. So I'm going to go up here to the core group, expand that, then expand input, and I'll click the number node twice. Now, I don't really need two of them necessarily, but I'm going to go ahead and put two of them so that I can have a different value for X and Y. But if you want the same value for both X and Y, then you only need one of these. So let's try, I don't know, 5 in the X and maybe 10 in the Y. And you can just type in any number you want there. And then what you do is you click on the port on the right-hand side. That's an output, right? So here we have inputs, and these are outputs. And you just click there, and that starts creating this wire. And then you just connect that wire to the input of the next node. And you can see in the canvas that the point has already moved over 5 units. And if I wire this one up to Y, you can see it moves up 10 units. If I reverse these, right, notice that you can only have one wire to an input at a time. So by connecting that one to the X, it disconnected the one that was already there. But I can kind of crisscross them that way, and it will go the other way. Now, you can only have one input at a time, but you can have multiple outputs coming out of the same output. So notice that if I wanted 5 in both directions, I only need one number node. So those are a couple different ways that we could, create a point and then, sort of move it around. Okay, now this is all very basic stuff initially here, but just sort of like a warm-up exercise to get us started. So that's what I'm calling, sort of the, the geometry equivalent of hello world, right? Create a point and kind of move it around, right? So very easy to do. Now, what this is saving you from is having to know C# or something and know the code that you would type in to actually program that same thing happening, right? But if you were working with the Revit API, you would use some programming language, and you'd have to write it out, code, a text code. So what the nodes really are doing is just making it a little easier because they're already pre-built, and it avoids a lot of typos because quite frankly, one of the biggest frustrations when you're first learning coding is all the very particular syntax, and sometimes if you miss just one letter or one comma or something, it'll throw the whole thing off. So you can avoid a lot of that with visual programming because a lot of this is sort of pre-built in. What you can't avoid, this is still programming, so what you can't avoid is logic errors, okay? If I come over here and I create a string instead, and I type the letter A here, and then I try to feed that in to the Y coordinate, that's going to generate a warning. And I'll get this little note up here that says one or more of the input types is not matching. In other words, when we hovered over this input in the first place, it said it needed a double, and the default value was 0. Now, double is one of those computer science terms that you'll just have to get used to. There's a lot of that sort of lingo here that you'll have to kind of learn. But double just basically means a double byte precision number. Okay, so in other words, when you see double, just think number with a lot of decimal places is what that means, versus a string, which is text data. Now, even if I took this string and put in a numerical value, it still wouldn't work because this string is formatted as text. Okay, you can see the same thing in Excel, right? There are certain functions in Excel that require numbers and others which require text, and so you have to match up the correct values. So again, in terms of what this shields you from programmatically versus what you have to know programmatically, it shields you from having to write all the code longhand, but you still have to understand the logic, you still have to understand the lingo, so the difference between a number and a string and things like that. Okay, we'll see more of that as we go along. Okay, so what are we trying to do? Well, ultimately back here, we were trying to place families along that path. Well, let's look for a node then that lets us place a family. So I'm going to go down to the bottom here, and there's a Revit branch, and that Revit branch gives me several things I can do in Revit. And what I want to do is create a Revit element. So I'll go to this elements branch, and then under element again, this gets a little confusing sometimes, right? Oh, sorry, it's not element again, my fault. See, this is why some people just like to go right to search. But of course, the trouble with searching is that you have to know what you're searching for, right? So when you're a beginner, you don't know what the names of all the nodes are, so what are you supposed to search for? So I'm going to go ahead and keep doing it through the library here initially, and then I'll switch to search a little bit later. So it was under family instance is what I was actually looking for, and then I'll do by point. Okay, so by point just simply means, right, that I'm going to create an instance of a family at a location. Okay, now this is a good way to kind of, especially if you're a beginner, to kind of figure out how to set this up. Like, how do you know where to start? Well, think about what you want to end with. I want to end with a family placed in my model. So what inputs does that require? So when we look at family instance by point, if you hover over it, it gives you a little message and it's giving you some more information. Not every node does this, but some of them do. So if you read through that, sometimes that's helpful. But there are two inputs. So one is family type. In other words, which family do you want to place? And the other one is point. Well, hey, we happen to have a point right here. So what if I just took that point and fed it in there? Okay. Well, that's great. Okay, but now before I'm going to see anything, I still need to feed in that other input. So now I'm going to come up here under selection. So still under Revit, under selection, and then there's an item here called family types. Excuse me. All right, family types is a drop-down. And if you expand that drop-down list, it will list out all of the families that are in the current Revit document. So if you remember at the beginning I said you have to start with a Revit document open. So Dynamo is just reading that Revit document and giving you a list of all the families that are in there. Now some of these you could place, it just gives you the full list, right? But some of these wouldn't make sense to try and place. Like you couldn't place a baluster because a baluster is part of a railing. So it would fail if you chose that. So you do have to know what's possible in Revit. Dynamo is not going to create new functionality that doesn't exist in Revit. It's just simply working with Revit. So what I'm going to do is kind of scroll down here to the R's and look for my RPC trees. And it doesn't really matter which one I choose here. So I'll choose this golden chain one, right? And then feed that in. And you won't see anything happen here in Dynamo just yet, but if we move this out of the way, notice that we do have a tree, and that tree is at 5, 10 or 10, 5. I forget which way I set it up, but it's at that point that we indicated. Now, that's not exactly what we were looking for. We said we wanted to put trees along that path, right? But we're getting there. We're kind of working our way up to it. And the point that I'm trying to make here is if you start kind of at the end of your graph and think about what you want to create and then work your way backwards, then you can, kind of almost, it's almost like, like a reverse wizard kind of walking you through the process. Just by looking at the inputs that are required, you can start to figure out what you've got to feed in there, okay? Now, placing a single tree using Dynamo actually is more work than just doing it in Revit. So if you just needed to place a single tree, then just do it in Revit, okay? Dynamo wouldn't be very useful for you there unless you're going to do something with that tree further down in the graph, okay? But we wanted to place multiple trees, and specifically we wanted to place them along that curved path. That was kind of our goal, right? So let's back up here and think about it. Okay, we need to feed a family type. We've got that. And we need to feed a point. Well, it turns out that there's a big part of working in Dynamo is lists. So you can feed one point into this port, or actually you could feed in a list of points. So what we're actually going to do is create a list of points, and specifically it's going to be a list of points that follow that curve that we have back there in Revit. So the first thing we're going to need to do is grab the curve from Revit so that the Dynamo understands the curvature that we're working with, and then we're going to ask Dynamo to find points along that curve. Okay, so those are the two things that we want to do here. Okay, so let's think about that. How do we get that done? Well, right here under Revit selection, there are some really general selection nodes here called Select Model Element and Select Model Elements with an S. Okay, so you've got singular and plural. Now, if I look at both of these, they both have a button. They function a little differently. So what I'm going to do is kind of move this way over here and then move this way out of the way so that we can see Revit in the background. Because the way that this is going to work is you're going to click this select button, and then it will put Revit in a selection mode. Now, the Select Model Element node wants one thing. So I'm going to click on the spline, and then that node is happy. So when it's yellow, it means it's not happy yet. Okay, you haven't satisfied the node. It doesn't necessarily mean there's anything wrong. It just means that there's some condition of, that's not satisfied yet. And in this case, there wasn't a selection. The number here, 3247, that's the element ID of that Revit element. So if we go to Manage under Inquiry and we do Select by ID, if you type in that number, 324278, and you click OK, it will actually select that spline. So that number just simply represents the unique Revit element ID of that thing. Okay? All right, so I'm going to deselect that. Now I'm going to click the Select button on Select Model Elements. And this one is a little bit trickier because the only way that you can use this selection is either with a window or a crossing. So if you try and click, it won't work. Okay, so what you do is you just click and drag, and I'm going to do a crossing selection here, and I'm going to grab both of those model lines. And you'll see I get two element IDs. And that's really the only difference between those two selection nodes. So if you want to select just one element, you can use this one. If you want to select multiple elements, you can use this one. Now, these are, again, both very limited selection nodes. A little bit later, I'm going to show you a different way to select that's a little bit more, what would we say, like surgical, okay, where you can actually reach into the model and say select all the elements of a certain kind or certain family or something like that. So that's a little more efficient than having to manually go in and pick them. But in some cases, manually picking them is all you need to do. Now, let me just adjust the 3D view here, and notice what happened. So even though we selected Revit geometry, what happened was Dynamo converted that Revit geometry into Dynamo geometry. So we've got these Dynamo paths now that represent those Revit elements, okay? All right, so far so good. We've got our two selection nodes. I'll just kind of move those over here. And then the family instance by point, I'm going to kind of push that over here. And I'm going to disconnect this point for right now, okay, because we're not going to need that for the time being. We're going to create points a different way. So I need to put some stuff in the middle here, okay? So the next thing that I want to look at is even though we created these, or we selected these two elements, the Dynamo graph still needs to, it still needs to be turned into something that the Dynamo graph can work with. So again, that notion of there's a difference between Revit geometry and Dynamo geometry. Sometimes you need what I'm going to call a bridge node. Now, I don't think that's the official Dynamo term for this, but that's just what I'm going to call it. So we're going to bridge between what we currently have and what we're trying to create. Okay, so there's a node called element.curves. Now, this is going to be the first one I'm going to search for. You could go looking for it again in the library, but let me show you how the search works, because I promised you I would show you that. So I'm going to do element dot, and at some point, if I just start typing, it'll start to find it, right? And so the first item that comes up is the one that I want. Okay, and it says curves right here, so that's the name of this node, and what it does is it pulls the Dynamo curve out of the Revit selection. So right now these are the Revit elements, but we're going to convert those into Dynamo curves. Now, curve in Dynamo is the mathematical sense of the word curve. So if you think back to high school math class, and I apologize if that's a painful memory for anyone, but a curve is just some linear element with a start point and an end point. And if you find the shortest distance between that start point and that end point, you have a special case of the curve called a line. But a line is really just that. It's a special case of a linear curve. So we can have curves that are curvy, like this one here, or that are straight, like this one here. But as far as Dynamo is concerned, they're both curves. Okay, so that's one of the things you just have to know from kind of computer science logic in order for this, to make sense. Now, if you're trying to find where things are in the library, actually, there's a link right here, and if I click that, it will take me to the branch of the library. So there's Revit, Elements, Element, and then finally Curves. So if you start off searching, but you want to kind of learn the library, that could be a good way to do it, because it'll take you right there. And, I use a combination of both. Sometimes I browse for things, sometimes I search for them, just depending on what my needs are at any given time. So if I take this element here and I feed it into element.curve. So again, I'm going to take the single element here and feed it in. Now, just to kind of make this clear, if I select this node, it'll highlight that. And then if I select this, it kind of highlights it again. I don't know if you could kind of tell there's a little bit of interference there. When I select this, there's really two things there. The thing underneath is the Revit element that we selected, and the thing on top of it is the converted curve that we asked Dynamo to create. So there's actually two different items there. It's this curve now that we're going to ask Dynamo to work on, and what we're going to ask Dynamo to do with it is to divide that curve up into a series of segments, or in other words, to find points along that curve at equal spacings is really what I'm trying to say there. So there's a parameter or a node for that called curve at parameter. Okay, so again, if we go through the library, right, we could get there from geometry. So where's geometry? Right here. And then we've got curve. And then under here, we've got point at parameter is what I'm looking for. Where is it here? Down here somewhere. Point at parameter right there. Or you could just type curve dot point at, and eventually it would show up in the search, right? So again, it's really up to you how you go about this. So there are two inputs here. Curve, which, right here, pretty good bet that those two will match, so I can feed that right in. If you tried to feed in the element, the Revit element, it would fail, right? So you see how I get a warning here that says, those two don't match. So it's really important to match data types. That's why we needed this intermediate node, or what I call the bridge node, to bridge between the Revit element and the Dynamo, the curve, right? So when we feed it together that way, everybody's happy, okay? So curve. Now, param, what does that mean? Well, Parameter at which to evaluate. That's not really very helpful. Double. Okay, well, remember, that's a number, and the default value is 0. Well, what you need to know about anything that says parameter or param is that's a value between 0 and 1. So you can kind of see where we are right now because the default value is 0. It's at this end of the at the curve here. I'm going to grab one of these number nodes over here, select it, do Control-C to copy, Control-V to paste, and paste it in right here. Now, I said a valid range is between 0 and 1. If I feed in 10, we're not going to see anything at all. Like, see how there's no point over here? Well, it turns out it's there. It's just way, I can't even find it, but there it is. It's way out there because 10 puts it way off the curve at some tangent point. Not very useful, okay? So, oh, sorry, let's zoom this back up again. Okay, there we go. That's a little bit better. Okay, so we don't want 10, but let's put in 1. And now we're at this end. What if we put in 0.5? Okay, now we're at the middle, 0.25. So now you're starting to see what the computer programmers call the domain of this parameter. And the domain just simply means the valid range. Okay, so a valid range for this input is between 0 and 1. So we want to make sure that any values that we feed into that param input fall within that domain. Otherwise, we're going to get something weird happening, like the point way off in hyperspace. Okay, so we want to keep it within that range. All right, so at this point, what's coming out of here is a point. Now, the last thing I want to show you is not the last thing, I'm sorry. The next thing I want to show you here is that sort of like a very basic thing is that you can see output from every one of these nodes, okay? So if you hover over it, these little pop-ups appear and then they go away if you move away. Those are called preview bubbles. Now, if you move your mouse down to the preview bubble, there's a push pin and you can click that push pin to keep that preview bubble open. And what you see here is that the output of this node is actually a point, which is exactly the same thing as what we created over here. See how output here is point, output here is point, which means that if I came back over here and I feed this one into here, we've already seen, that gives me a tree off the path. But if I kind of move this so we can see both, and I feed this point in instead, now I get a tree on the path, okay? So we're making progress. We're getting there now. We've got a point. It's on the path. And, of course, if I change this to something else, there's 0.1, here's 0.5. You can see that that's moving the tree around, but keeping it on the path, all right? So what I want to do is instead of just having one point at parameter, I want to create a bunch of points at parameter. So how do we do that? Well, that's our next major concept in Dynamo. I already alluded to it. I said Dynamo is all about lists. Okay, so lists of information are really important in Dynamo. So lists get generated for all sorts of things. So we're going to go up here to the core branch and then look at the list branch. And at the top, there are 3 really basic ways to create a list. You can just create a list with a random number of items that you indicate, you know, so you can do 1 item list, 2 item, 3 item, or you can do a range or a sequence. So let's do range. Now, when you create a range node, let me just kind of create that all by itself. Notice that if I hover over that, there's already 10 items on this list. You see how it says 10 there in the little curly brackets? So what I'm going to do is kind of hover down here, click the push pin, and look at that list. So the range node has 3 inputs. The start input is a number whose default value is 0. The end it could be a number or a letter. Notice it says number or letter. The end one is defaulting to 9, and then the step is how much space we want between each number. That's defaulting to 1. Okay, so let me just quickly show you how this works. Let me grab one of these number nodes here, copy and paste it again, and let's say that we just feed this into the start node. Well, notice the change that it had in the list there. Now we started at 0.5. We're still stepping by 1, so it goes 1.5, 2.5, 3.5 until it gets to 9 items, right? Because we're asking for we're ending at the 9th item. Now the other thing you're going to notice here is it actually goes 0 through 8. It doesn't go 1 through 9. So another computer science thing, another programmer thing is that programmers start at 0. So you're just going to have to get used to that, okay? So the first item on a list is always item 0, which means that your count is always off by 1 if you're thinking in a 1-based list versus a 0-based list. Okay, what if I change this to right there? Okay, well now I asked to start at 0, to end at 0.5, but to step by 1, which means that I only get one item on the list, because if you put in item 0 and then you add 1 to it, you're already beyond the end of the range, right? So it can't give you anything there. What if I change this to 5? Okay, well now I get a 5-item list. What if I put that in the step instead? Well, now I'm starting at 0, I'm ending at 9, the default, but I'm stepping by 5, so I'm only getting 2, right? Or now I'm getting 2, 4, 8, you know, up to 8. So if you vary each of the inputs, you're going to get a very different list each time, okay? So the point is, you just have to decide what you want to input into each of those 3 inputs in order to generate the list that you're after. Okay, so I'm going to introduce you to another node to make this a little bit more interactive, and that is a number slider. Now, we're going to feed this list ultimately into the param value, replacing this static node number here, okay? So let me just move this out of the way a little bit, and we're going to make room for the list in here. So remember what we said the range was. We need to start at 0. We need to end at 1. Well, our default value for start is already 0, so nothing to do there. Our end value is currently defaulting to 9, so we're going to feed in a number node there and change that to 1. That's the end value we want. So now we know that our first value will be 0, our last value can't be more than 1. So now the step we're going to control with this slider. Now, if we just feed this in, it's really not going to work too well, because notice that the domain of this slider is very large numbers, which well exceed 1. So we want to change the domain of this slider so that it goes in fractions between 0 and 1. And you do that with this little triangle right here. And you could say the minimum value is 0, the maximum value is 1, and the step is 0.1, for example. Well, now, as you change this slider, right, here's a 0.1 value, here's 0.2, here's 0.3, 0.4, and eventually you're going to have a very short list because it doesn't work anymore. So it's going to work best at these smaller values, which means you might want to change this to 0.5, or you might even want to change this to 0.05 so that you get a little bit more range in here. However you do it, right, I'm going to stop at 0.2 because that gives me a decent quantity. It gives me 6 items and they're spaced 0.2 apart, okay? But as long as you build your slider in such a way that it works within the domain you're after, then you should get nice results. So now I've got all of this. Let me just kind of move that right about here, and then take that sequence and feed that into the parameter value, okay? So what does that do for me? Well, at the moment, it doesn't look like it did very much. Notice that I'm still getting only 1 point. So I've got 6 parameters, but for some reason, it's only generating 1 point, and then back here in Revit, it's only generating 1 tree. So what's going on here? Well, there's another really important concept that we have to understand when working with lists in Revit. Lists have a certain way of matching up with one another. So I'm going to show you a couple different variations of this, but we call these ways of matching lists with one another lacing. So there's 3 values. There's shortest, there's longest, and there's something called cross product. So shortest lacing takes 2 lists, and it just comes up with the smallest number of pairings possible. So if you have a list of 2 items on the one hand and a list of 4 items on the other hand, you're going to get 2 pairings because it's going to take the shorter list and just match up item 1 on that list with item 1 on the next list and item 2 with item 2, and then when it runs out, it just runs out. If you do longest lacing, it'll actually use the longest list and match everything up. So it'll do 1 to 1, 2 to 2, but then when it runs out, it'll just match the last item on the short list with each of the remaining items on the long list. Okay, so you're actually going to get the last item on the short list used over and over again in order to satisfy the longest lacing. And then with cross product, if you had 2 and 4, you'd end up with 8 total pairings because it's going to match everything to everything else. Okay, so what we have to do is decide which lacing is going to work here in this scenario to give us what we're looking for. Okay, now in order to really help you understand that, I'm going to switch to the selection that includes both lines, because if I just show you with the curved line, it'll look like longest and cross product lacing are doing the same thing, and it might not be completely clear. But I think if we do it with at least 2 objects, it'll be a little bit easier to understand. So I'm going to take this model element 1 and move it out of the way and replace it with the select model elements 1. Notice that already had an impact on my list here, and that already had an impact back here in Revit. Now, what happened may not be what you expected. What we actually got there was item 0 matched to item 0, and you got the first tree on the first point on the curve. And then it went to item 1 and item 1, and it shifted point 2, and it gave us this, and then it stopped. Because shortest lacing says, I've got a 2-item list, right? 2 curves, 1, 2, and then I've got a 6-item list, 6 parameters, and it just says match the first 2 items with the first 2 items and ignore the rest, okay? So what would happen if we took this thing, right-clicked it, and changed the lacing to longest? See how it's shortest by default? I'm going to change it to longest. Well, now I get a total of 6 points, because what I described longest lacing was, is it item 0 to item 0, item 1 to item 1, then it ran out. So now it's going to take item 1 on the shorter list and match it to items 2, 3, 4, 5, and 6 on the longer list. And what we get is closer, but still not quite what we were expecting, right? We don't have a tree in the first node here, and all the repeated trees are along the straight line. They're not on the curve, right? So what I was looking for was along the curve. Well, now if I switch to cross product lacing, right-click, lacing, cross product, it will match every pair or every item on both lists with every other item on all the other lists, and you get something like this. Okay. Now, I started to say that if we had kept the original selection back here, a 1-item list instead of a 2-item list, then cross product would have worked, or longest lacing would have worked. Okay, so longest. And that's simply because you match item 1 to item 1, and then you match item 1 again, which is the last item on the list, to every one that remains. And so in this case, with a 1-item list, longest lacing and cross product would really give you the same thing. But I think to fully understand lacing, you need to have a list with at least 2 items for it to make a little more sense. And that's why I switched to this select model elements to kind of illustrate that. Okay, so again, longest lacing looks like this now. So you can see, hopefully, how this graph came together. I can delete the stuff we don't need. Sorry, I'm adding things instead of deleting things. There we go. Can delete the stuff that we don't need. Let me just maximize this up here and just kind of remind you of what we had, right? So we've got 2 elements. We turned those into curves. We fed that into this point parameter. We created a range of values here with the number of points, fed those in. And then finally, the lacing is what is the magic sauce that determines that you're going to get those repeated points along the curve. And finally, we create those families right here, and we get all those families along the curve. Okay, so that's a really simple example. And again, there's a lot of foundational skills in there. So we talked about lists, we talked about lacing, we talked about nodes and wires and how they connect, and data inputs and matching input types, and warning conditions. There's a lot of depth in that simple, seemingly very simple example. Now, I do have enough time, I think, to show you the other example I wanted to show you, which is something that's maybe a touch more practical, something you might run into every day in your work. And again, it's just to kind of show you a variation of something that we can use Dynamo for. So one of the things that's very powerful about Dynamo is its ability to help us do repetitive tasks, okay? So what I'm going to do is close. Usually you want to close in reverse order. So I'm going to close this graph, not save it. I'll keep Dynamo running, and then I'm going to close my Revit file here, and I don't need to save that either. I'm going to actually open the sample project. I'm sure you've all seen this one before, right? The advanced sample project. Sorry, basic advanced sample project. There it is. Right. So everybody's seen this one before, no doubt. This is the little school building that that they've got here in the, provided with the software here. Now, it's only got 2 sheets at the moment. Okay, so I'm going to come down here, right-click this, create another sheet, accept that, rename it, because I don't know why it went to A4, so I guess they had an A3 previously, and I'll just call this elevations. And I'm going to throw a couple, let's minimize Dynamo there, I'm going to throw a couple elevations on here. So maybe I'll do the north and the south and perhaps the west. Okay. So a little sloppy, I'm off the screen there, but I didn't place the east or this courtyard elevation. So at this point I've got 3 sheets, and the floor plan sheet has just one thing, the section sheet's got a bunch of stuff, the elevation sheet's got a bunch of stuff, and so a lot of times people will have an office standard that says if a view is on a sheet, we want the name to be uppercase, and if it's not on a sheet, we want to keep it lowercase, right? So let's say that that was your, your office standard. Could we use Dynamo as a way to help us with this? So I'm going to go ahead and walk through this graph here. Now, I have it already, and I'm going to open it and just sort of walk you through it as opposed to building it from scratch, because I'm not sure we have the time to build it completely from scratch here. But very important thing here is the previous graph was running automatically. So that's a really nice way to work in a simple graph, because as you make changes in the graph, it's happening immediately in Revit, and you can see those changes in real time. But sometimes you want to evaluate the graph first, make sure everything's what you think it's going to be, and then run it when you're ready. So notice when I select an existing graph here, there's an open in manual execution mode checkbox here. So I want to make sure that's checked so that this thing opens but doesn't try to run immediately. So I'd rather explain it to you first before we run it. And this may not be, well, it might be the right one. I don't know if this is the completed version. Let me see if I've got another version of this. I might have to go with that one because I don't think I have the completed version. All right, so let's go with that one. It's close, so I'll have to add a few things to it. Okay, so all right, so the first thing I'm doing is, instead of selecting model elements where I have to click on them in the interface, and that would be tricky to do anyway because we're talking about sheets and views, right? So how are you supposed to click those? Instead, I started with a node here called All Elements of Category. So this will look at your Revit model, and it will find all the elements of a certain category. And then here, from the list of categories, I said views, okay? All right, so far so good. Now, there's another cool thing that we can do where we can, and I'm going to kind of move this out of the way here. I'm going to take this one, right-click it, and freeze it. So what that means is I can start right here and just run these 2 nodes without it running the rest of the graph. So let me click Run. Okay, so there's my list of views now, okay, that are currently contained in this file, and there's 43 of them, okay? Now, over here, this one generated a warning with a strange dereferencing pointer. Well, what's happening here is I asked it for the element parameters. In other words, if you want to know all the parameters that are available for a particular element, you can actually use this node, and it will list them all out for you. So they have title on sheet, they have color scheme, associated values, et cetera, et cetera, et cetera. And what I was looking for was to find you know, all of the parameters that I could access, because this node right here that I've frozen says get parameter value by name. And this is one of the most powerful things you can do with Dynamo, is you can reach into your Revit model and you can grab the value of a particular parameter. And then you can take that parameter and do something to it if you want to. So let me unfreeze this, and I'm going to freeze this one instead. Okay, and I'm going to run it again. And this one is asking for the view name. So string value, again, just means text. So the input here for parameter name needs a string. So view name, you've got to type it exactly like it appeared here. So that's why I wanted to get all the list of parameters, just to make sure I'm typing it correctly. Otherwise, you know, you do trial and error to figure that out. But anyway, I feed in the list of views, and then I ask them all what their view names are, and here they are, right? So there's all the view names. Now, actually, what I want to do is copy this right here, both of those nodes, paste it, and the other parameter that I want to ask it is what the sheet number is, because the only views that I want to rename are the ones that are assigned to a sheet. Well, if you look at a view back in Revit, you can just do this right in Revit to see, right? So if I select the west elevation here and I scroll down, it will tell me what sheet number it belongs to, but that's a read-only value. If I select the east one, it'll be empty for that value, okay? The sheet number isn't even listed there, right? So there is no sheet number for this value, okay, or for this view. So that's what I'm looking for, is whichever ones come up with a sheet value. Let's run it, okay, and here it is. So now I'm only seeing A1, A2, A3, right? Those are the ones that I want, okay? So I can limit my selection now to just the views that actually have that sheet number value assigned to them, okay? So we started with, you know, totally different way to select. Instead of trying to select individually, right? If you're going to select everything manually, you might as well just do it in Revit, right-click and rename and do it yourself, right? What we're trying to do is get Dynamo to intelligently select everything for us. So I said, give me all the views, but now I want to say, just limit your work to those views that have a sheet number, because those are the ones I care about, okay? So we're going to do something called a bool mask, which sounds kind of funny, but it's bool is short for Boolean, and a Boolean is two values: true, false, yes, no, up, down, left, right. Okay, so what you want to do is get a list. You basically want to look at this whole list of values here and ask them, do they have sheet values or not? And if they say yes, they'll be true, and if they say no, it'll be false, and then we'll just take the true values, okay? So I'm going to do a node here called starts with, and I guess I didn't spell that right. Oh, there's an S right here. Okay, so this is a string value, right? And if I click on there, you can see it's under string, it's under core, and then it's under string, and it starts with, and it's got 3 inputs, okay? So we need a string value, and I'll bring that in, and I want to just put in capital A. Okay, so what I'm searching for is capital A, and then I'm going to take all of these values coming out of this list and feed those in, and then ignore case defaults to false, so we're not ignoring the case, which is sort of like a double negative. Anyway, let's run this and see what we get, okay? So here, if I expand that, you see how I get a bunch of trues and falses. Now, it's still kind of in this warning state, and that's because number 18 is a null, okay? I don't have a lot of time to explain why that is, but the simple answer is not everything on this list is actually a view. Some of these things are view templates, which kind of throws a little monkey wrench into here. So what we want to do is just tell it to ignore the nulls, okay? We don't care about the nulls. All right, so we can actually do that with another node, and let's see. Yeah, well, let's do our bool mask first. I really wish I had the completed version here. Sorry that I'm running short on time now. Let's do bool mask. Bool mask. Okay, so what does bool mask do? You take a list and you take a mask. The mask is a list of trues and false. Okay, that's all the mask is. All right, and there's a node here to remove nulls, and I want to just get rid of that. So let's see. Where are you? Let's try remove. Now I can't find the remove nulls. Oh, how about clean? I think clean will do it. Let's see. Let's find out. Let's take this list, feed it in here, and run it. And it still says 43 though. Yeah, that's not the one. Shoot. All right. Well, I'm out of time. Let me try and get this to work. Okay. So I'm going to take my list here of views, the original list, and then I'm going to take my trues and false, and then we need something called a watch node. And the only reason I need a watch node is because there's two outputs coming out of here. So if I use the preview bubble, it'll put them all together in one list. And all I care about is the ones that are true. So I'm going to wire that to a watch, and because of the null, it's not working. All right. Well, let's run the original graph, which is going to rename everything. It's not exactly what I was looking for, but because I'm missing the piece here, this is always what happens when you try and improvise live. Let's just run this piece. This is actually a little different graph. This is going to change the every single view to uppercase, which isn't exactly what we were looking for. What we were looking for is to just uppercase the ones that were coming out of the sheet. So because I'm having a hard time finding the remove nulls, that's where I'm running into the trouble here. But let's just run this and see what happens. Okay, so here's what this is doing. It's taking this list and it's just forcing them all to uppercase. And then we use a set parameter by name. So we go back to the original list of elements. We're using the same parameter name, the view name, and then we're just making them all uppercase. So just watch the project browser over here when I run this. And of course, I'll get this message in Revit. You've all seen this before. When you rename a view or a level, it wants to rename the corresponding. I'm going to say no here, okay? And notice that everything just went to uppercase. Now, that wasn't exactly what I was looking for originally. This is a much simpler version of the graph, and this is just arbitrarily making everything uppercase. But it does show you the possibility. So if I get the filtering to work to filter out just the ones that are true that are on sheets, then we can limit that effect to just the uppercase. Now, the only thing you want to be careful of at this point is this is a live graph running here. So at this point, you would probably want to close it, okay? And I'm going to actually, let me do a save as on this just in case anybody has a question about this before I close it. So let me just, put a letter at the end. So then I can close it, okay? Because, I don't want it to try and run again while I'm working in Revit. So that's the kind of graph that you'd probably only run when you're ready. And in fact, that's a great one to run in Dynamo Player. So now that we've kind of started with Dynamo Player, it brings us full circle back around. So if you build one of these, you can hand it off to the team and say, hey, when you want to rename all your views that are either on sheets or not or whatever, assuming you get the other one to work, you can just run this Dynamo Player and they don't even have to open Dynamo to do it.